I want to demonstrate the regression analysis that was discussed in your text. In the example from the book, they have quantities that they've found, the price that they were charging at the time, and what the advertising was at the time. And they've got all that data, and now there are 12 data points for each one of those. And they want to see, well, what is the relationship between what I charge for my product and what the quantity I sell is, and the same thing for advertising. And in the first example in the book, they discussed the simple regression, which is just the price versus the quantity. So I can do that a little bit differently than they did in the book, and I'll do it also the way they did it in the book. But first, let's look at a more simpler way when you have only the two variables. You can create a scatter diagram like this and add in the data points. Now the data point we want for the X value on this occasion is going to be price. There's the data I put in there. There's the vertical axis, and I get this smattering of data. Okay, now I right click on one of the points and say add trend line, and down where my options are I say display the equation on the chart and display the R-squared value, and there's the answer. The equation is y, which is the vertical, which in this case is quantity, is equal to minus 1.5778 times the x, which is the price. The horizontal axis is the price, plus 210.44. So that would be the equation for the best fit line through those data points. And the r squared, which is the coefficient of determination, is 0.8891, rounding off to 89. All right, what that means is 89% of the variation in that data is explained by that line, the equation of which is the one we just set. So that's a really good fit. So there is a significant relationship between the price and the quantity, and that's the equation that defines it. Okay, so that's the easiest way to do one with two factors. All right, now let us go to the way they did it in the book. And in order to do it the way they did it in the book, we would have to go to a data analysis tool. The data analysis tool should be on your computer if you took statistics. If it's not, it's loaded into every Excel program. And you need to go to add-ins and add it in if you haven't already got it on there. Okay, so you can go to help, work Microsoft Help, and they'll show you for your version of Excel. They'll show you how to get the data analysis tool pack added in. So this is the data analysis tool pack, and all the options I'm picking regression. All right, so let me go now to OK, and first Y range I pick is going, my Y range is the Q's. So I'm going to take the whole column this time because you can do it in this particular application. And the next one is the price. Those two against each other. And I do have my labels, and I want to put it on C23. That's good enough for me. Let's put it on C23. There it is. There's the ANOVA. Now look what we have in this ANOVA analysis. Look at the coefficient. The R squared is 0.88906. That's really close to the same thing there. And the coefficients down here, the intercept is 210.44, which is the same as we got up above. And the coefficient times price is minus 1.57778. And let's look up here. That is the same thing we got here. So we can do it in this way, the regression. We get more information when we do it this way. We have the R squared right there, which says that 89% of the variation in the data is explained by the regression line. The adjusted R squared is a number you only have to look at if there's a significant number of variables that you're trying to explain with not very much data. When the adjusted R-squared is only a few points or two away from your R-squared is valid. So we would usually on this one just say that the R-squared is 0.89. Now, down below we have the F statistic. The F statistic here for this one is 80. Now, there is two ways to look at this. There is an F table you can find on the internet. The F table will tell you what this test F would be. Anything larger than a test F would mean significance, okay? But in this format, we don't have to worry about the F table because here they have what they call the significance of F. And here you can see it's a very small number, 4.3 times 10 to the minus 6, that's essentially 0. Anything less than 0.1 would indicate that the F-squared is the F is a valid statistic. What the F statistic is it says that the equation that you've made, the collection of variables, is significant. And that becomes more of a factor when you have a multiple regression, more than one independent variable. So here, more than one dependent variable, I meant to say. So here is one other thing I want to point out is t-stat, that t-stat column, when the absolute value of the t is greater than 2, you have a significant statistical coefficient here. And if you look at the coefficient for price at minus 8.95, the absolute value of that is 8.95. That is greater than 2, meaning that that coefficient is significant statistically. And the p-value is another way. The p-value is the probability that I have found this result by accident, and the probability is close to 0. The guideline is your probability here, your p-value, should be less than your level of significance. And since I'm doing a 95% confidence, the level of significance is 0.05. I'm substantially below that. Therefore, I have a significant correlation between the price I charge and the amount of goods that I sell. That is the bottom line of what we're learning here. Now, do the multiple this time. The multiple would be to redo the data analysis tool and again do regression. Only this time, okay, so for the Y values, we're going to use the same thing. But for the X's, we're going to include both of these. We'll do them both. And where I want to, I say that I use the labels. You have to do that or you'll get a messed up answer. I've used the labels at the top of the column. And now I have to pick a point where I can put this chart and it won't mess up my page. So I'm going to pick that point right there and have it put it there, okay? So now I have the regression analysis for the two variables. And the R-squared is now 0.96. I have now explained 96% of the variation in the data, which means that I now have a way of predicting by knowing what my price is and knowing what my advertising spending is. I can predict what my quantity sold will be. All right, and the adjusted R-squared is still very, very close. And let's see if we can get over to the F-squared. Read that one. The F-squared significance is still very low. If the significance is below 0.1, you're in good shape. So what that F means is that we have an equation that is working. It is not accidental, this equation. It is seems to be describing what is happening. Okay, and now there are two variables this time. There is the intercept, of course, and then there's the price, minus 1.3 times the price, plus 11.25 times advertising. That is the equation. The equation is quantity equals the intercept 116 minus 1.30788 times the price plus 11.24592 times advertising. That will give you what your quantity should be if you put your variables at different levels. Okay, the t-stats are good. This one is absolute value is 10. Anything greater than absolute value of 2 is good, meaning there's a correlation. And this one is 4, which is above 2, which is a correlation. The p-value here is very small, also very small here, less than the 0.05, and so I have determined that this equation that I just generated seems to predict what quantity I will sell when I adjust price and advertising. I hope this helps you out when you're reading that chapter. If you have any questions, you can come to the forum. Thanks.